The Eternal Student here, and today we'll be going over the Production Possibilities Curve, also known as the PPC. Now, the PPC is usually the first diagram you'll encounter while studying economics. The textbook definition states that it is an economic model that shows the production possibilities of an economy that only produces two goods. But what does this actually mean? Well, to demonstrate how it works, we're instead going to look at it from another angle. Imagine you've just started studying the IB and have 1 year before you need to submit your applications for university. You'll need to make your application as appealing as possible, and you can either spend your time on sports or academics. How are you going to use your time? We can plot this on a graph. Let's put sports achievements on what we would call the y-axis, and academic achievements on the x-axis. Your inputs are the hours you can use to spend on either, and the outputs are the achievements and accolades you could receive in either field. Now, there's only so many resources at your fingertips because the number of hours in a year is fixed. Let's also just assume for every hour you spend in either field, you're working at maximum efficiency. Well, we can draw a line that kind of shows an inverse relationship between the two. You'll notice that when sports achievements are high, academic achievements are low, and vice versa. This line is what we call your maximum productive potential, and it basically represents the best version of your efforts, i.e., what you could achieve if you used every single waking hour to 100% efficiency. You could be at any position along this line, so long as you're maximizing your productive efficiency. Alternatively, since this line represents the maximum position, you could technically be at any position within the line, shown by the shaded green area. Now, we can go through a couple of examples to demonstrate how this works. Let's say you spend all of your time doing sports exclusively, training for competitions and participating in inter-school events. Now, you'd have a wonderful physique, but will probably be somewhat behind in academic ability. No pun intended. Therefore, your opportunity cost of doing all that sport would be getting a good grade. On the other side of the spectrum, let's imagine you spend every waking hour instead making notes, revising your lesson material, and studying diligently for your tests. Although you bring home top grades, odds are you'd have a less than stellar physique, a weak immune system, and a conspicuous lack of attention from the opposite sex. Now, if you're somewhere in the middle, you'd have some level of sporting ability, but wouldn't be the sportiest, and also have some level of good grades, but wouldn't be the absolute smartest. However, you'd still have a good level of overall accomplishment by combining both. Now, what happens when we're inside the curve? Well, you'd be underachieving respective to your full potential. If you don't make the best use of your time, say you're too addicted to doom scrolling on your phone, or you don't believe in being constantly stressed and overexerted and just want to chill, well, economists would call this an inefficient state where your resources are not being employed fully. Finally, we have the area outside the curve. Now, this represents the mythical ideal of both being a god at physical ability and academics. However, this is unobtainable, as there's only enough hours in a year to do so many things. Well, except for this guy, obviously. Now that we've gone over how this graph works, we can take it back to its rightful home and look at how it would apply to a hypothetical economy producing two types of goods. Capital goods, which is just a fancy way of saying goods used by businesses for production, for example tools, machines, equipment, and consumer goods, which are goods used by consumers, anything you and I could buy. Instead of hours, the inputs into production are now the factors of production. Let's assume this economy is maximally efficient. If we start at point A, we can see we're making 80 units of capital goods and 60 units of consumer goods. We also have a point B, which produces more consumer goods, but fewer capital goods. Now, if we wanted to move from point A to point B to make more consumer goods, we could. We would probably need to shuffle around some resources, but after doing so, we would be able to produce 60 more units of consumer goods, but at the cost of 35 units of capital goods. Therefore, the opportunity cost of producing those extra 60 units of consumer goods is 35 units of capital goods. Now, the PPC is rather straightforward, which makes it simple to understand, but this is also what makes it rather limiting. Firstly, it can only really show the trade-off between two goods, which makes it rather unrepresentative of the real world. Another issue is that it assumes resources are fixed within a country and do not change. In the real world, countries may discover new resources such as oil and precious minerals in their country. Thirdly, it assumes that resources are always being used efficiently. And finally, it assumes that technology levels are fixed and do not change. In the real world, technology is constantly developing. For example, before the existence of ChatGPT, students actually had to be creative at cheating. Now, we could show how new resources and technological progress could affect the PPC. Let's say we're looking at an agricultural economy that only produces apples and oranges. If the country develops a better form of agricultural technology that increases their harvest, or let's say annexes a neighboring country and takes its land and resources to use for farming, they will be able to produce a higher total amount of both apples and oranges. Hence, the PPC would move outwards, representing economic growth. On the other hand, if instead the country is stuck by biblical floods that destroy most of its arable farmland, or if one day aliens decide to pull a prank on them and steal all their tractors, then the economy wouldn't be able to produce as many apples and oranges. This is demonstrated by the PPC moving inwards, which represents an economic decline. The last thing to note is that up until now, we've been drawing our PPC kind of curved. However, we could very well draw a straight line PPC too, so what's the difference? Well, in the case of a straight line PPC, the opportunity cost is constant. If we have the option to produce either lattes or cappuccinos, two very similar goods which use the same resources, we can see that every time we want to produce more cappuccinos, we end up giving up the same ratio of lattes. As we go from A to B and B to C, we produce 5 more cappuccinos every single time, but give up 10 lattes each time. What this means is that resources are perfectly substitutable between the two. There is no trade-off between producing lattes or cappuccinos. However, if we look at two much more different goods, let's say lattes and fighter jets, we can see that the PPC resembles its usual curved appearance as we've been drawing up until now. Here, when we go from A to B, we have to give up 20 lattes to produce one extra fighter jet. And from B to C, we have to give up 35 lattes to produce one extra fighter jet. Every extra fighter jet seems to require more lattes to be given up. This is because in this case, resources may not be perfectly substitutable. Odds are your average barista doesn't know how to create precision-tooled jet panels or construct a missile targeting system. Therefore, the resources we redirect from making lattes may not be a good match for making fighter jets, and so we have to use more and more of them to compensate. And we're done! Time to review the syllabus statements. So the PPC does come up with some regularity in the exam, so you'll be expected to remember quite a bit about it. Now, IB have set out the syllabus statements for this section in a very confusing way by trying to link it with the key concepts I mentioned in the previous videos. But here's what you need to know. You need to be able to define what the PPC is and what it represents. You need to be able to explain how it works and use proper terminology in the process. You need to know what it means to be on the frontier, below or above it, and also how the frontier may move. You need to know the limitations of the diagram. And finally, for the HL students taking paper 3, do expect some graphing and some rudimentary math questions that ask you to calculate opportunity cost. Now for increasing versus constant opportunity cost, this is never tested on its own. I have never seen a question asking you to explain factor substitution, but you're expected to have at least some level of knowledge on it. And with that, you're done. Thanks for watching, and I'll see you next time.